Hello everyone, welcome to EduShore. How are you all? I'm Dr. Suman Pawar. If you remember last time we did the concept of real numbers, we introduced you to the number system that we originally deal with, and that is also called the one-dimensional system. So today we are going to extend that concept to the two-dimensional system, and we will introduce the concept of complex numbers to you. Okay. So first of all, we will discuss what do you mean by complex number, why the concept of complex numbers has originated, what led to the need for knowing complex number and going to two-dimensional geometry. Okay. So basically, when did we realize that we needed complex numbers? Okay. So for example, if you take a real number, okay, suppose x is a real number. So if you multiply x with x, what will happen? Okay. So you know the law of trichotomy. According to the law of trichotomy, if x and 0 are real numbers, then either x will be less than 0 or x will be equal to 0 or x will be greater than 0. So this is the law of trichotomy. So if x is a real number, either it is negative or it is 0 or it is positive. So if x is negative, so x times x will be positive. If x is 0, then x times x will be 0. And if x is positive, then x times x will be positive. So you can see that x times x, which in shortcut can be written down as x square, is greater than or equals to 0. So because of this property of squares, we are going to deal with something very interesting now. So now, if suppose you encounter the equation x square plus 1 equals to 0, okay? Suppose you want to solve this equation. So what do you want to do it? So you will say x square is equal to minus 1. So do we have a real number such that x square is equal to minus 1, which is negative? So do we have a real number such that its square is negative? No, the answer is no. The law of trichotomy says that we cannot have a real number whose square is negative. And therefore, what kind of numbers are going to satisfy this? Now comes the concept of complex numbers. So we define x is equal to under root minus 1. Now this is square root of a negative number. Square root of a negative number is never defined in real numbers. Now this is known as iota, denoted as I, and this is the imaginary number. Okay, imaginary, or this is also known as iota. Iota also means imaginary. So this is called iota. Okay, so let us now delve into the complex numbers. So what are complex numbers? Okay, so what are complex numbers? Complex numbers are defined as z equals to a plus bi. Okay, where a, b are real numbers and I is under root of minus 1. So complex numbers have two parts. One is a simple real part, and this is called imaginary part. Okay, this is called imaginary part. So A is called the real part of Z, B is called the imaginary part of Z. So what does it mean? It means that my complex number now has two dimensions. One is the real dimension and one is the imaginary dimension. So how do we plot it? Now, in case of real numbers, we plotted it on a number line, a straight line, which was one dimensional. So to plot a complex number, we will have to go into two dimensions, a two-dimensional plane. So this is x-axis as we plot two-dimensional points. This is y-axis. Okay. Now, x-axis will be denoting the real part of z, and y-axis will be denoting the imaginary part of z. So for example, if my complex number is 1 plus I, so that means my real part is 1, my imaginary part is 1. This is my complex number. This is the location of my complex number, which is nothing but 1, 1. Okay. If you look at z is equal to minus 2 plus 3i, so this is going to be minus 2, this is going to be 3. So this is the location of minus 2, 3. So the complex numbers will be spread over space and there is no well ordering property. So we don't know which complex number is bigger and which complex number is smaller. Okay. So there is no ordering property over here, but you can see that they're spread out in space. So we are plotting the real part on the x-axis and we are plotting the imaginary part on the y-axis. Okay. So this is how we plot a complex number. Now, let us come to the concept of absolute value of a number. Okay. Let us come to the concept of absolute value of a number. So we will do it in two parts. One is real part and one is complex part. Okay. And complex number. Okay. So we know that we are on a real number line. This is 0. So for example, I say what is the absolute value of a number? What is the absolute value of 1? Now these two vertical lines is the sign of absolute value. So absolute value of 1 is distance of 1 from 0. So absolute of value of 1 will be 1. Similarly, absolute value of minus 1 will be distance of minus 1 from 0, which will be 1. So in fact, if you take x to be a real number, the absolute value of x will be x if x is positive. The absolute value of x is 0 if x is 0, because the distance of 0 from itself will be 0. The absolute value of x will be minus x if x is negative. Obviously, because if we are looking at absolute value of minus 2 is a negative number. So I multiply it with a negative sign to get plus 2, because absolute value indicates distance and distance can either be 0 or positive. It can never be negative. So that is the concept of absolute value of a real number. Absolute value of a real number is not a technical concept. It is the distance of the point from 0 and therefore we are giving it a positive sign. Okay, we are not interested in right or left. We are just interested in the distance. All right. Now, what do you mean by complex number? Now you can see that complex numbers are just an extension of real numbers, because if I have a real number x, then I can write x as x plus 0i. So the imaginary part is 0. For example, if I have a number 1, 0, it will be plotted here. Okay, so this is 1 plus 0i. So this is nothing. Ye number line hai. If I look it in a 1D plane, in a one-dimensional setup, this is a point. Okay, but अगर मैं 2D में देखूं तो ये complex number है 1 plus 0i. So complex numbers are extensions of real numbers. So real numbers are subsets of complex numbers whose imaginary part is 0. So they are lying on the real axis only. Okay. Now, let us extend the concept of absolute value to complex numbers. So, according to you, what should be the definition of absolute value of a complex number? You see that absolute value of a real number was the distance of that number from 0. 0 means reference or starting point. The reference or starting point in a 2D plane is 0, 0. Which is nothing but 0 plus 0i. This is the 0 of complex numbers. Okay. So for example, this is my a plus ib. Okay. So this is my a, this is my b. So this is a plus ib. So if I say what is the absolute value of a plus ib, that is nothing but the distance of the complex number from the reference point. So this is nothing but distance of a comma b from 0, 0. And according to the distance formula, it is going to be a minus 0 square plus b minus 0 square, which is a square plus b square. So that is the definition of absolute value of a complex number. Now, if you don't know the distance formula, there is a way to derive it. So you want to know this distance? Okay. You want to know the distance? Let us call it as A. Let us drop the perpendicular. So according to Pythagoras theorem, suppose this is my distance X, this is my distance Y. So according to Pythagoras theorem, X square plus Y square is equal to D square. What is your X? Your X is A. So A square, what is your Y? Your Y is B. So B square is equal to D square. So D will be under root A square plus B square. And that is basically how you derive absolute value of a complex number. So what is absolute value of a number? Absolute value of a number, whether it is real or complex, is the distance of that number from the reference point. So in case of one-dimensional setup, the reference point is 0. That means nothing. In case of a two-dimensional setup, the reference point is 0, 0. That is also known as origin. Now, these are technical terms, but you have to understand that absolute value, whether you talk in terms of one-dimensional case or two-dimensional case, or later on in case of 3 dimensions, absolute value means distance of that number or the point from the reference point. Okay, so that is the concept of absolute value of a number. So what have we done? We have introduced you why complex numbers were introduced, because we could not solve x square equals to -1 and many more equations like that. And therefore, iota was invented. I is equal to under root -1. So that added one more dimension in our kitty. That is the second dimension. So for example, if you draw a rectangle, you cannot draw it on a line. A rectangle needs two dimension, length and breadth. Okay. So any point on the rectangle, if you put it on a 2D plane, it's a complex number. Okay. So then we studied what is absolute value of a number. Absolute value of a number is nothing but its distance from the reference point. So whether we are on 1D or we are on complex number plane, the absolute value means out to the same thing. Okay. So I hope you got something out of the class today. See you in the next class. Thank you.